Good day to Dr. Nozalila. Here is Group 10 to present the introduction of Wheel Mobile Robot report. In the construction of a robot, there are three main elements to be considered, which are locomotion, kinematics, and dynamics. Locomotion is how the robot would move around. Kinematic being the mathematical study of the motion minus the force applied on the robot body itself. Dynamics refer to the study on the motion of the robot. For this project, the LEGO Mindstorm EV3 software and hardware were used. The software allows users to code and program the robot. To briefly introduce the system, there are several key blocks to be identified. First, the brain of the system. The EV3 bricks serves as the control center in which it is instruct every part of the robot according to the program inserted. Next, the servo motor, categorized into large and medium motors, is responsible for the robot's action. However, do take note that the medium motor is better at performing tasks at faster response compared to the larger counterpart. Lastly, sensors are the input to assist the EV3 bricks in assessing its environment and thus make proper adjustments or corrections to its action accordingly. Examples of the sensors are gyro sensors, ultrasonic sensors, touch sensor, and color sensors. Next, the objectives of this project is to build and program a two-wheel, self-balancing LEGO Mindstorm EV3 mobile robot using the brick structure, motor, and sensors, and investigate the function of the EV3 bricks and the electronic components that build up the two-wheel, self-balancing LEGO Mindstorm EV3 mobile robot, as well as to study the programming of the configuration blocks to perform desired tasks such as the line follower and avoiding obstacles. Moreover, the task 1 in this project is wheel mobile robot to move forward and backward following black straight line. Firstly, a wheel LEGO Mindstorm EV3 mobile robot is built up from the LEGO Mindstorm EV3 Home Edition set. Then, an extra ball bearing is attached to the back of the robot to act as the steerable driver wheel. The motors are ensured to be connected to the output ports of the EV3 brick. Next, the LEGO Mindstorm EV3 color sensor is attached to the mobile robot. The sensor is ensured to be connected to the inputs of the EV3 brick. The figure shows the final wheel mobile robot built up for the line following task. After the programming blocks are modified, the experiment setup is done by creating a black line on the floor using tape. Then the modified program is downloaded to the EV3 brick, which serves as a control center and power station for the wheel mobile robot. The EV3 brick is receiving the input from the sensors and sends the output to the motors. The wheel mobile robot is then put at the start of the black line before the operation is started. The selected program is executed by pressing the center button on the EV3 brake. The wheel mobile robot will then start to operate the task 1, moving forward and backward following the designed black line. Here is the video of the task 1. Furthermore, for the discussion is the analysis of the programming. The figure demonstrates the programming blocks for the first task, which is moving forward and backward following a black color path. Since the program used the color sensor in color measurement mode, therefore the color sensor was set by changing to color measuring mode to detect specific colors. To create the program, a loop was plotted to repeat the program with a timer set for the time required for completing the path. Then the power of the motors was adjusted to be 75 to initialize the forward movement of the robot as well as smoothing the robot movement. An if block, which is also known as switch statement, was then created to check the color detected by the color sensor and modify the program if it is true or false condition. For the first case, black color was chosen. and the A motor and D motor were set to 0 and 75 respectively. Hence, only the D motor will move and turn away from the line when black color is detected. For the opposite case, where black color was not detected, the A motor and D motor were set to 75 and 0 respectively. Only the A motor will move and turns towards the line when other color is detected. Next, the robot was set to run the program in the loop for 11 seconds before it stopped. Finally, the wait time was set for 2 seconds before it moved backward. The same algorithm was used for the backward movement, but with negative values set for the motor's power to reverse the motor's rotation direction. After several attempts, the results were acceptable. The robot had successfully traveled in a forward direction through the path. It turned towards the black line when it detected the other color and turned away from the line when black color was detected. However, when the robot was programmed to move in a backward direction, it encountered some problems where it could not move back several times. At first, the robot was having difficulties moving smoothly on the path because the ball roller was not rolling properly and stuck for a few times. We had to request the technician for another ball roller, which can roll smoothly. Sometimes the robot was unable to identify the path, possibly because of the color sensor not being close enough to the ground. Therefore, we adjusted the position of the sensor to bring it closer to the surface of the path. As many students has used the robot previously, the robot jammed and got interrupted when we tried to test our program. Hence, we have to delete and clear all the previous program to execute our program without any problems. In addition, the task 2 of this project is the self-balancing two-wheel mobile robot avoid obstacle while moving by utilizing a medium motor and an ultrasonic sensor. First, we remove the ball bearing and change the sensor to gyro sensor and the ultrasonic sensor and attach it to the mobile robot. The sensors are ensured to be connected to the input ports of the EV3 brake. The figure shows the final self-balancing two-wheel Lego Mindstorm EV3 mobile robot built up for the obstacle avoidance task. Then the drive control loop is modified. Before operating the wheel mobile robot, the experiment setup is done by placing two obstacles in diagonal form at a certain distance in front of the robot. The wheel mobile robot is first held and balanced with the hands before the operation is started. It is then let go after the selected program is executed by pressing the center button on the EV3 brake. It will then start to operate task 2, avoiding obstacles while moving by utilizing medium motors and an ultrasonic sensors. Here's the video of task 2. The discussion of the task 2 is the analysis of the programming. A loop was created to repeat the obstacle avoidance while moving forward. The first block of programming is the ultrasonic sensor block to detect the presence of the obstacles by emitting ultrasonic waves. Firstly, the ultrasonic sensor measures the distance between the ultrasonic sensor and the obstacle. A wait time of 3 seconds was set and followed by a loop. When the distance was out of 30 cm, the wheel motor moved forward at a speed of 15. Then, waiting for 2 seconds, the loop was repeated. When the distance detected was within 30 cm, the buzzer will beep and avoid the obstacle reverse with a speed of 10. Then 3 seconds of wait time for balancing and then the robot turned right with a steering value of 25. After 2 seconds, the robot moved straight with a speed of 20 for 20 seconds to completely avoid the obstacle and balance itself at the same time. The robot turned left with a steering value of -25 and moved forward at a speed of 10. After wait time of 2 seconds, it moved forward at a speed of 15. Lastly, the program robot re-entered the avoid obstacle loop. In short, when the program was switched on, the robot kept moving forward when there was no obstacle in front of it. When the distance of the obstacle was within the set range with the robot, the buzzer created a beep sound. Then it moved backward and turned right to avoid the obstacle. It turned back to the left and moved forward until it met with another obstacle. Lastly, the robot was able to avoid obstacles and then continue its forward movement. One of the challenges in this project is the EV3 brake is not working well. This is because the robot has been used for a long time and has not been upgraded enough. The connecting ports at the robot are loose, which causes the cable to not firmly connect to the port. Hence, it is important to ensure that both ends of the cable are tightly inserted into the ports. Besides, a suitable wait time must be set to avoid the robot from falling due to inertia. Several wait times were set and tested to decide the most convenient wait time. This is because the lesser wait time will cause the robot to be unbalanced, while longer wait time will waste the time to wait for the robot to continue its movement. In conclusion, we will successfully build the robot and program it with software. The robot balances itself on two wheels using gyro sensor and runs forward and backwards and avoid obstacles detected by ultrasonic sensor. Next, the line following program is successfully coded such that the robot follows the black tape using the color sensor. Lastly, all the objectives in this project have been achieved by us Group 10. That's all from Group 10. Thank you.